Now, today's topic is Gauss theorem. Okay, so to know this concept, Gauss theorem, let us consider a closed surface, and in this closed surface, take a charge q which is enclosed by it, that surface. Then, what according to Gauss theorem? Gauss has said that the electric flux that is 1 upon epsilon times the total charge enclosed by that surface. Suppose this is a surface and this is the closed surface, and suppose it consists of charge q. Then what Gauss said that the surface, that the flux is equals to 1 by epsilon naught times the charge enclosed by that closed surface. Okay, so this you can flux you can write. How can we write flux? That is surface integral E into ds is equals to 1 upon epsilon naught into q. Okay, so the definition of Gauss law is that it states that the surface, this is the surface integral. Okay, the surface integral of electric field intensity for a closed surface is 1 upon epsilon naught times the charge enclosed within the surface, within the surface. Okay, now then after we come to know, that is the EDS is equal to 1 upon epsilon naught q. So how to define Gauss theorem? The surface integral, this is surface integral of electric field intensity for a closed surface. See the definition I am explaining. Surface integral of electric field intensity for a closed surface is 1 upon epsilon naught times the total charge enclosed within the surface. This is the definition of Gauss theorem. Now see the proof. Proof of Gauss law from Coulomb law. Okay, for this, consider a sphere. Okay, and let us consider a sphere. This is a sphere. Okay, now at the center of this sphere, suppose a charge q is placed. At the center of a sphere, a charge q is placed. Okay, then suppose this is r distance apart. The radius of this sphere is r, small r. Okay, now how to calculate the electric flux? So for complete surface, if you want to calculate the flux of this complete surface, then we have to choose a small area. As I already explained, if you want to calculate the area of a whole wall, so you have to choose, you have to what you have to do, you have to take the area of small brick, then you have to integrate. Same way, you have to take a small area. Suppose this is the area and at its area is ds. Then already I have explained the area vector of the surface is always perpendicular. This is the area and this is the perpendicular, so the direction is perpendicular. Area vector is now we have taken a we are considering a sphere. Okay, and at the center, at the center we are taking a small charge, plus q charge. Here also plus q charge. So what is the electric field? You know that electric field due to plus is always outward. Okay, now I know, then area vector is also outward. Well, okay, now what is the angle between these two, E and ds? What is the angle between E and ds? Because they are aligning in the same direction, so angle is 0, and they are parallel and aligning in the same direction, so angle is 0. If they are aligning in the different direction opposite to each other, then the angle is 180, and they are aligning in the same direction, so angle is 0. So here the angle is 0. Okay, and we are considering also here a small element of area ds. Okay, now as according to Coulomb's law, now see, according to Coulomb, suppose if we want to calculate electric field intensity here, suppose, and we have to choose a small test charge. So what according to Coulomb's, what the force exerting between here and this test charge is q0. Okay, this is the test charge here, and test charge means the charge. What do you mean by test charge? Is that charge which is used to detect the presence of electric field. Okay, so what is force here? Force is equals to 1 upon 4 pi epsilon naught q into q0. Q between q and q0 here. Okay, now this is the force, and distance is r square. Distance between q and q is r, and so r square. So what is electric field intensity? That you know that it is the force upon test charge. So on putting this value, what is the value of 1 upon 4 pi epsilon naught q0 r square upon q naught. Q naught cancel. So what is the value? What is the value? That is come. Now electric field is equals to 1 upon 4 pi epsilon naught and q upon r square. Are you getting? Q0 cancel, q upon r square. Now put this is equation 1. Now we already know that what we know that the flux is equals to what is the integral of E ds, and I have already explained this. You can write E ds cos 0. Why 0? Already I have explained you. The angle between them is 0. Now what is the value of cos 0? E ds cancel. E ds cos 0 means 1. So this is the electric flux coming. Okay, now flux is equals to, we can write, because electric field is this side and this is the surface with respect to surface. And what is the surface area of sphere? Very good. What is? E into 4 pi r square. Surface area of sphere is 4 pi square. So from this is equation 2. Now put the value of E from first in second. So what we get? Electric flux is equals to E. What is the value of E? 1 upon 4 pi epsilon naught q upon r square into, what is the value here? 4 pi r square. 4 pi cancel, r square cancel. What is remaining here? Flux is equals to q upon epsilon naught. Hence proof that flux is equals to 1 by epsilon naught times of the total charge enclosed by it. Thank you.